Hello, Geezer here again. In this video I want to talk about greenhouse gases in a little bit more detail and try to explain how they do the things they do in our atmosphere. But before I get into that, I want to go back and just review this graph that we looked at previously. And one of the things that you can notice is that all those bands, the orange ones and the blue ones, all except for the red bands, really start to taper down as the time goes on and towards the end of the current century. And you would ask, well, it's going down, we're reducing emissions, so isn't that enough? What's the problem? Well, here it is, and it's a bathtub problem. I've mentioned that term before. The issue with carbon dioxide in the atmosphere, it's a little bit like water in a bathtub. We put CO2 into our atmosphere just the same way you'd turn on the spigot and fill up a bathtub. The issue is with this bathtub, there is no drain. You don't see a drain in the bottom of my little schematic bathtub here. And that's the same issue we have with our atmosphere. There's really not a sufficient drain for the CO2 as we put it into the atmosphere, the CO2 and other gases. So even though emissions are decreasing with some of these scenarios, we still have CO2 in the atmosphere, and that causes a problem because it collects up there. CO2 is in our atmosphere is a very stable molecule, much more so than some of the other greenhouse gases. It can reside in the atmosphere for hundreds, even up to 1,000 years. So once we emit and it goes into the atmosphere, it tends to stay there. So what is our CO2 concentration today? Well, the number I'm showing is not today's, but it's fairly recent, and our CO2 concentration is a little bit over 400 parts per million and continually growing month on month, year on year. And I had somebody just ask me recently, or comment recently, 400 parts per million isn't very much. So why is that a problem? Well, small amounts of chemicals in the atmosphere, or anywhere for that matter, have the ability to do pretty amazing things, sometimes good, sometimes bad. Think about cyanide gas, which at 4 parts per million is lethal to humans. So, and talking about 400 parts per million, or greater than 400 ppm in our atmosphere of carbon dioxide is a problem for us. And, let me explain exactly how that problem works and manifests itself. Drawing that I put together, please don't make fun of my drawing. I don't have to worry about copyright because nobody's ever going to take my drawing, but what it's trying to represent is we have solar radiation, solar energy impinging on the Earth. And on the right side, we see it impinging and hitting plants. And, plants absorb CO2. It's part of the photosynthesis event, and it's absorbing CO2 and the heat energy from the sun. So one of the things you'd say is, well, there's the problem solved for the bathtub. We'll just plant more trees and more plants and problem solved. But that's not the case. We don't, unfortunately, have enough arable land to plant enough trees to make a difference in the carbon dioxide concentration in the atmosphere. So while planting trees and greenery is never a bad thing, it's not nearly enough of a solution to the problem that we have. Now on the left side, on the blue area, that's supposed to be sea ice, polar ice caps. And we see solar energy impinging there, but there's also a ray going back up into the atmosphere. And, you know, while the heat energy can melt polar ice caps, which in and of itself is a problem because our sea levels rise, it's also a problem as we start to reduce our glaciers and polar ice cap, because it's a reflective white surface, and the heat energy can reflect off a white surface, right? It reflects off white and absorbs by black. So it's a double whammy with what's happening with our polar ice caps melting and getting smaller. We're reducing the amount of area that can be reflective, and we're also increasing the amount of seawater, which is increasing our sea levels. But I want to get right to the point of it. There in our house in the center, we have solar energy and heat hitting the house, and again, it can reflect back off the house, but on the air conditioner on the side, as we're running air conditioners to cool off our house from the solar heat energy, that some of that heat from the air conditioners is also being reflected into the atmosphere. So while we're cooling the inside, we're warming the atmosphere. But really, the main part of this drawing is the little CO2 diagram right in the center underneath the sun. And carbon dioxide really is a linear molecule in that sense. There's a carbon with 2 oxygen bonds on either side, and what happens when it absorbs the solar energy, the infrared radiation, it begins to it's like springs. Those bonds are like springs, and it begins to shake like this, oscillate. And what happens eventually, it will emit some of that heat back out. But the problem is, heat energy that was going to go up out of the atmosphere is now getting trapped into this motion, and so the energy, some of it that was going to go out, is now being reflected back down. And that's the mechanism by which CO2 works. So it's insidious, it's a problem, and we don't have, even though we're reducing emissions in some of these scenarios that we're talking about, we have CO2 up there, and we need to reduce it by other means. And one of those means is carbon capture, and that's the topic of an entire video, how carbon capture can work. It's a technology that is being developed. All right, so let's just look at where we are with CO2. I mentioned we're just over 400 parts per million. This historic graph shows CO2 levels over the past several 100,000 years, and while there's been some variability up and down, it's maintained at around 300 parts per million for a very long time. And only in the last 100 years, where we've really started burning fossil fuels and emitting greenhouse gases, it's gone up substantially, well above 400 part per million. So it's a very steep increase, and that, that's the problem that we have to solve. So I hope this helps your understanding of how the greenhouse gases are working and doing the things that they do, and why it's so important that not only we begin to reduce and continue to reduce emissions, but we also have to come up with ways to take it out of the atmosphere. Thank you. Do sign in and check out my YouTube playlist, Geezer Talks Climate.